Okay, we are in a discussion of AWS solutions architect, and we're going to start a new topic. We're going to be looking into database management with AWS. It says RDS. Actually, we're going to be looking into as a whole, not only RDS. We're going to be looking into non-RDS as well, like data warehousing, analytical site, analytics. All together, we're going to talk everything in a one shot. It might be a few videos, but I'm going to go with everything, right? All right, let's go into introduction to databases. Actually, thinking to do a little bit introduction, but it's not going to be very deep. So, why database matters? Database self application is to organize and retrieve data efficiently, right? Unlike prac files, that slow down as data grows. So databases maintain perform with increasing volumes, allowing developers focus on application logic rather than data management, right? The availability and performance of your application depend on significantly on database when you choose and how it's configured. So a lot of front-end systems like web pages we get in today, searching, they come in through many times in the databases, queries coming through the databases, right? So we have in AWS Solutions Architecture, get to talk about a few different databases, right? Basically, they go into two main categories: relational databases, non-relational databases, right? So relational databases, non-relational databases, actually they're going into more further, like relational and then semi-structured and then NoSQL, like that, right? So relational databases structure data in tables with predefined schemas, uses SQL for queries and ideal for complex relationship and transaction. So basically, mostly RDS in AWS, MySQL, PostgreSQL, Oracle, Microsoft SQL, right? uh, IBM DB2. Uh, and these are the ones examples for relational databases. And then we go to non-relational databases like semi-structured. They can be document databases, right? And JSON, BSON files. So flexible schema for unstructured data, optimized for specific data models and distributed architecture. So examples, DynamoDB, right? DynamoDB is a millisecond uh, latency databases of fast access. MongoDB, the document sort of type, right? And Cassandra, they are the sort of non-relational databases, right? All right, so relational databases, structure and SQL. So relational database organize data into tables with columns and rows, similar to spreadsheets. So you probably have, if you're in an IT field and has been studying them, you probably in your past you probably have encountered experience with databases, right? Long time ago. Remember, we started with the long time ago, like we started with the DBase, right? Lotus sort of things a long time ago, 90s. And then they developed Access, Microsoft Access, another database. And now they developed into SQL. And then now they on cloud as well. Earlier for in on premises. So if you have a spreadsheet, it's a bit of you can get an idea. So each column requires a predefined name and data type. So your ID, your name, something like that, and their fixed order establishing relationship between data point. You get so many different type like numerical data, so text data, strings, right? Logical, yes, no sort of data. So this structured approach allows for efficient data storage, retrieval, and management through structured query language (SQL). So once you arrange data in the tables and then you use your primary keys, secondary keys, and relationship between data to retrieve data back and present it in a very nice format in a through a web page, right? That's how it does. The front end, the database is going to be in the back end. So multiple related tables are commonly used to avoid redundancy and improve query performance. So it will use multiple tables to get a query faster, right? While AWS architect don't need a deep SQL expertise, understanding the core concept is essential for working with AWS managed data service. So the relational databases, the table structure contain columns, we call attributes, and then rows, records, right? Tuples. Each column has predefined name and data type, creating a constant structure for all data entries. Like an example, you might have an institution and then you're probably giving your a student number. So everything are based on a student number. So we'll search a student number, then we'll get a student's name, and where students join, what sort of courses they following, something sort of thing. So term relational come from how data relate across tables using primary and foreign keys. Tables can link to minimize redundancy while maintaining the data integrity. So you probably have seen, if you study databases, you can see primary and foreign key, which gives you to retrieve data to get various different complex SQL query. So SQL allows user to select. Select is like finding data, searching data. Insert is inserting new data. The update is updating existing records, and delete data is deleting existing records in the database, and join clauses enable combine data from multiple tables. Like let's say you join this year, and then who's doing a networking course is this student, something like that. So join different tables. All right. So basically, we are talking about sort of a different sort of a data in databases. So here you got OLTP and OLAP, but you got still one more called analytics. So OLTP means online transaction processing data, just like in a financial institution, e-commerce website. So you process online transaction, and then OLAP means online analytical processing databases, so complex queries and huge data, business intelligence sort of things, right? And data processing types. So relational databases can be configured as either online transaction processing or online analytical processing. So configuration depend on a specific application need and performance requirement, right? Uh, OLTP databases normally optimize for frequent read-write operations, handles multiple transactions per second, e-commerce website, fast routine and predictable searches, high memory requirement to store frequently accessed data. So example, e-commerce platforms, banking systems, right? OLAP, online analytical processing databases designed for complex queries or large data sets, requires significant compute and storage resources. Commonly used data in warehousing applications, that's basically for warehousing. Often consolidate data from multiple OLTP sources, example, business intelligence and reporting systems, right? All right, so Amazon Relational Database Service, RDS. What is Amazon RDS? RDS is Managed Cloud Service that simplifies running relational databases in cloud. So whatever we are running like Microsoft SQL and all other databases, we've been running in our own premises. Uh, RDS we running them in the cloud, right? It automates time-consuming administrative tasks as hardware provisioning, database setup, patching, and backup. So RDS allow you to create new databases in minutes while offering flexibility, customize data bases across 8 engines and multiple deployment options. So it's making our life easy. So ready-made databases are there. Are a lot of things happening in the background, like backing up, right, patching, and a lot more things. Whatever we're doing in on-premises, so maintaining and managing tasks go off while customer can focus on the application and retrieving data and managing the application. Simplified management. So RDS automates critical tasks, including in RDS environment, so storage infrastructure, database backup, software and OS maintenance, and patching, update, all being done by AWS. So you don't need to worry about them, and you just need to concentrate on your application. RDS provide robust security with integration with identity and access management, resource level permissions, VPS deployment options, encryption capabilities, data data in transit and data in rest. Data in transit SSL certificates you can use, and then data in transit you can use KMS, key management services. So basically RDS, you got these 8 supported multiple database engines. So it's a MySQL, MariaDB, right? Oracle, PostgreSQL, Amazon Aurora, and Microsoft SQL Server. So these are going into category of RDS, right? Relational database system. Right? Okay, so let's quickly have a look at these engines. So here listed 1, 2, 3, 4, 5, 6 engines, right? MySQL. So optimized for OLTP applications like e-commerce and blogs, right? Uh, it does offer latest community edition versions, right? Um, and then Oracle. Oracle is a vendor provided database, right? So you have a standard edition SC1, SC2, SC, and Enterprise edition for a specific requirement. And then Amazon Aurora AWS database, right? And it's a drop-in replacement for MySQL and PostgreSQL, right? Right efficiency, right? The past SQL, so past 5 times faster than normal RDBMS, right? Relational Database Management System, MariaDB, right? That's available as well, right? Uh, and then PostgreSQL, that is one of the advanced database type. And you have Microsoft SQL Server, right? 2008 R22 up-to-date editions, right? You can do seamless migration from on-premises implementations, right? Those are the ones available. RDS licensing and options, right? Let's have a look what is this. I can't much see, but don't worry about that. License include modules of free options, MariaDB, paid options, all MySQL, SQL Server versions, right? Benefit license cost integrated into RDS pricing, or you can bring your own licenses, some of them like Oracle, Enterprise Edition, SC, SC1, and SC2, right? Leveraging existing license investment and database option groups, right? All right. So these RDP database instant classes, right? Um, Most of databases with balanced performance, both the standard and memory optimized instances are EBS optimized, providing dedicated bandwidth for storage transfers, dedicated database for heavy performance requirement, right? And you have burstable instances, right? It's all depend on your peak time and non-peak times, right? Instant types, right? You can see uh, bandwidth and this throughput use cases. So standard DBM for most database workloads, and then memory optimized one, and then you have burstable instances as well. All right, key consideration for database selection here, right? So when you're selecting um, database engine selection. So this is a normal comparison. SQL versus NoSQL database. We haven't discussed any NoSQL databases yet. So choosing from six popular engines in RDS, right? So you can select these six popular engines and then license models. So license, some of them are BYOL models, right? And then insert class selection. So which one you want to use is standard, memory optimized, or burstable instances. And then storage, you can use general purpose SSD or IOPS, especially IOPS ones, right? High performance workloads, or you can do magnetic or backward compatibility as well, right? And then we're going to discuss multi-availability zone deployment, right? So you have a standby as well as a read replica version, right? We're going to discuss them in the future, right? So that's, I think, this is for brief introduction, and we're going to talk more about these ones from next video. Until then, thank you very much. Okay. We are in a discussion of AWS solutions architect, and we've been discussing with uh, the AWS provided databases. All right, so previous videos I told you I'm going to be looking into the portal documentation quickly and give you guys sort of catch up about RDS. We discussed RDS and non-RDS and workloads. All right, so I will briefly go through this one, this documentation briefly. I'm just going to highlight the points, important points in this one, right? I'm not going to go line by line. All right, so Amazon Relational Database Service is a web service that makes it easier to set up, operate, and scale relational database in AWS Cloud. It provides cost-efficient, resizable capacity for an industry-standard relational databases and manage common databases administrative tasks, right? So the role of engine is they're going to discuss separately. I'm not going to discuss it separately. I'm going to tell you sort of highlighted features in Aurora in here as well. All right, so here they uh, mentioned advantages of RDS, right? So you can database engines like IBM DB2, MariaDB, Microsoft SQL Server, MySQL, Oracle, PostgreSQL. These are normally uh, coming under RDS, but IBM DB2 is, I think it's a little bit different. Commonly, it's not in there because it can't do some sort of customization, sort of whatever the features other RDS supporting, right? All right, comparison of responsibilities with the MS and EC2 and on-premises deployment, right? So So here, compute cloud provides scalable computing capacity to place cloud, unlike on-premises server. CPU, memory, storage, and IOPS are separated so that you can scale them independently, right? So this is sort of a idea and how the database can be deployed. You can see here in the features, right? And on-premises management, you could see everything is managed by customer. All responsibilities are on the shoulders of customers, and then easy to management. If you install something like a legacy database, or if you need by compliance, you need a root access, you need more control, then you can use EC2 environment. So about 70% or 80% is managed by a customer, only server maintenance, hardware lifecycle, and power network and cooling is managed by AWS, right? And then this comes to RDS environment. So RDS environment is a 95 or 99% customer only managed application. Everything else is managed by RDS. So this is the advantage of a RDS environment, right? Okay, so see that. So the instances are normally DB instance. If you create a Oracle or create a MySQL, PostgreSQL, IBM DB2, whatever you create is going to be inside the one of the availability zone, right? And then you can create or you can replicate this instance in the other areas, right? So this is the Amazon RDS application architecture. Normally, it can be a two-tier application or three-tier application, right? So this is a region, and then you got a VPC, and the VPC you have availability zone. One availability zone, there's another availability zone in the same region, right? And then here you have elastic load balancing, right? And the traffic goes through internet gateway, and then users connecting here through DNS resolution using Amazon Route 53. And then this public subnet, you got web servers, they're going to be auto scaling group according to the load, right? And then under private subnet, so you place your Amazon RDS instance, right? The security wise, private subnet, you have a instant level security group, right? That state full, and then you have subnet level protection network ACLs, right? Access control list, and then that can be integrated to use key management service AWS as well as IAM, identity and access management to access to a database, and then this availability zone can be used replicate to another availability zone. So here you got a primary database instance. So this is the one used for read and write queries. And then here you have standby DB instance. So standby DB instance is something happened to primary. You can use this one as a primary, can become primary through the DNS resolution, right? So the DB engines listed here RDS. So IBM DB2 also listed as RDS, right? So it says Amazon RDS support the following DB engine. So DB2, MariaDB, SQL Server, MySQL, Oracle, PostgreSQL, right? Okay, so then we're going to have a quick look how the regions and availability zones are affecting the high availability, right? All right, so you could see here the region one, right? So region one, you got the RDS DB instance, and then clients users accessing read write access here, right? And then you're going to have another region, another instance. This is use asynchronous replication. So asynchronous replication usually use less bandwidth. Also, it a bit of a delay from a primary instance. So initially it write into primary instance, then it's going to be writing into a secondary instance. So there's a little gap in between these two, right? So every data is here is not going to be here until a few delays, right? So, but the major advantage is this asynchronous replication in here in a different region. So you can use this RDS as a read replica. So it's going to be used as for read access. If you have a uh, read heavy workloads, so you can use uh, this one as a read access. So it does give you a sort of a disaster recovery, right? As well, or it gives you a regional use this in a different region. So it's basically accessing in a read write instance in primary region. This is easy to access. Let's say one of them in the US, the other one is might be in Europe or somewhere. So accessing this database in that customers possibly be faster than you're going to access this one, right? And this one is region to region. So keep remember this is important, right? And then you're going to talk about we spoke about availability zones, right? So there are two type of multi-availability zone uh, deployment. So the multi-availability zone deployment provide following advantages, right? So provisioning data redundancy and failover support. So primary engine fails, you can have a secondary engine, right? So eliminating IO freezes, right? Minimizing latency spike during a system backup, right? And serving read traffic on secondary DB instance, right? So that is on the cluster deployment only. Okay, so have a look at this is important, right? So availability zone, multi-availability zone deployment gives you high availability, right? See that you see that when you apply this one in a region, so this is primary database instance. So that is being used for read, write access, right? But once you deploy in here is a synchronous replication. That synchronous replication need more bandwidth, and it's writing into these two databases in the same time. But what you need to understand is this one is a standby replica, so you can't use a read access when you deploy it in the availability zone. Is a normal way, right? But there's a deployment called the cluster deployment. So when cluster deployment, right, you can deploy a different instance in a different availability zones. That's in replication, right? But the difference between this one and this one, now this is you can use read access all of others when you deploy in cluster deployment. So primary database is used for writing as well as reading, but the other availability zone instances you can use uh, read instance as well, right? So the difference is this if it's not a cluster deployment, then there will be is only a replica and high availability. But here you get a read access as well, right? And access control with security groups. So you can see here in the security groups, right? You can use a instant level security group, and then you can have network ACLs as well in that group, right? So that is I think the important highlights in a um, RDS instances, right? And you can use different ways this access. So RDS management console, command line interface, RDS APIs, right? Those three methods you can use. So if you want to more going into thoroughly this documentation, so you can go with this documentation thoroughly, right? RDS, right? So anything you couldn't understand, just read. You got a lot of details in here, right? All right, let's go back into our presentation. I'm going to go with some of the more highlights in these databases, right? So the first one is a service, and then you have a engine model, and then you got a performance because this table is bigger. I couldn't get them into a properly space in one single table, so I'm going to go with the three tables, right, and then another slides, right? So you have here Aurora, Amazon Aurora, right? The RDS, so MySQL, PostgreSQL engine. So you need to keep an eye. This one is normally 3 to 5 times faster than normal RDBMS, right? Also, it's auto scaling. So you can use whatever you pay, whatever you use, it automatically scales when the data growing bigger, right? Aurora, you can go up to 15 replicas. That's a huge, right? Faster workloads, right? And then normal RDS, this is a MySQL database, right? Relational. So it's standard performance, 5 replicas. You can deploy in multi-availability zones, right? And then PostgreSQL, standard preference, advanced indexing, and the JSON supporting, right? And then MariaDB, right? Compatible built-in analytics. So it can be used for analytics as well. So Oracle is enterprise grade, right? So vendor based. Bring your own license and license integration options also there, right? SQL Server, that is my SQL Server, MS SQL Server, Windows optimized, always on availability groups, right? DynamoDB is again a NoSQL DB, single digit millisecond faster. AutoScale DAX is the memory system, the acceleration support. So it has acceleration support, fast acceleration support, right? DAX, data acceleration support, right? So elastic cache, memory redis, and memcache, right? Sub-millisecond latency, high throughput, right? And then you get a document DB, semi-structured. So MongoDB, document compliance, better than MongoDB, auto scale, right? And then the Neptune graph database, graph optimize the relationship in variables. So it's SparkQL and Gremlin, right? One key spaces. So Cassandra white column, single digit millisecond and 99.99 available. Memory DB, memory Redis, ultra fast, durable, multi availability zone. So memory DB, so caching, a lot of things in the database gives you fast access, time stream. So 100 times faster monthly cost of normal RDBM, right? Let's go into next slide. Okay, hold on a second. Already it loaded. So couldn't get this one into one table. That's why. So same thing I'm going to explain. So Aurora high performance application, enterprise workloads, cloud native apps, right? And then MySQL web applications, e-commerce, content management, CRM, right? CMS. Okay, so PostgreSQL is advanced complex queries, data warehousing, geospatial applications. MariaDB, SQL, MySQL, alternative open source project enterprise applications, right? Oracle is enterprise applications, legacy systems, complex transactions, SQL Server, Microsoft, so basically Windows-based applications, .NET applications, the enterprise workloads, the DynamoDB, right? DynamoDB is NoSQL, mobile apps, web apps, gaming, IoT, real-time applications, faster access, right? Elastic cache, so session storage, real-time analytics, cache layer, gaming leaderboards, right? So you can use Elastic cache. So document DB is basically content management catalogs, user profiles, document storage, and then you go to Neptune, social networks, code detection, recommendation engines, knowledge graphs, key spaces, IoT applications, time series, data high volume applications, memory DB, real time application, session storage, gaming chat application, time stream, IoT applications, operational metrics, and application return, right? So again, same thing, the bit of a diagram is here. So AWS database service decision tree. What type of data do you need to store? So relational data, NoSQL data, specialized data, right? And then need high performance, you can go to Aurora, right? And if you don't need that much high performance, then you can go to normal RDMS, right? Sorry, RDBMS, and that's RDS. So you can go to MySQL web apps, PostgreSQL if you have complex queries, right? If you need an open source, then you can go to MariaDB, right? If it's a NoSQL, if it's a key value, fast access, you can go to a DynamoDB, serverless NoSQL, and then it's a type is a document, then you can go to MongoDB, right? If it's a graph type, then you can go to Neptune, and a white column, right? Key spaces, Cassandra compatible, right? And then here you can go to RDS Oracle, you want the enterprise level, and here you can go to Microsoft SQL Server if you have .NET applications and SQL type, right? And then here specialized data, so analytical cache in time series here, right? Then you can go to MemoryDB, Redis, and durability. Or if you don't need durability, so you can go to Elastic Cache, Memory Cache. Or if it's a time series, you can go to time stream, time series database, right? All right, let's go to next slide. We still got something coming up. All right. It take a little while to load. So AWS database services comparison part 2 continued. So because of database is too big, I couldn't represent in one single uh, database. So service key benefits is say CO3 focus. So let's have a look back again. Just reminding. So Aurora 5 times faster than MySQL, 3 times faster than PostgreSQL, automatic scaling, the high availability, performance, cost optimization, right? And MySQL, you can see basic RDS operations, right? PostgreSQL complex queries, right? And then MariaDB when you need open source, budget constraint, right? Oracle enterprise grade, right? Advanced security, Oracle like customized things you have, legacy, uh, SQL Server, .NET compatibility, Windows, right? Hybrid scenarios, DynamoDB, serverless single millisecond latency, auto scaling, right? NoSQL design, elastic cache, sub-millisecond latency, Redis min cache, and then you got document DB, MongoDB, and Neptune graph database, SparkQL, Gremlin, key spaces, Cassandra, and then memory DB, memory, microsecond latency, durability, and then you have a time stream as well, right? All right. So when we have a look at RDS backup and recovery, right? Let's have a look. This diagram gives you sort of an idea of backup and recovery timeline, right? So it's in a zero, and these dots gives you recovery points, right? And here's the automated backup. So it's an automated backup daily at 2 p.m., right? So 2 a.m. in the morning, and then incrementally 6 hours, every 6 hours, right? And then pull back up in a weekly, right? Let's say you got a recovery point here. So point in the recovery is a 15 minutes granularity, right? So within a 15 minutes granularity. And then so these backup can go cross-region replication, right? Asynchronous 15 minutes lag, right? Regional A to region B, right? And then see that disaster recovery scenarios, you can see the local time, RTO, right? Timing objective, right? Um, 30 minutes, RPO, right? Recovery point objective is 15 minutes, right? Source, local backup, auto failover, yes, and uh, T plus 30 minutes service restored, right? And see that regional disaster, RTO 2 hours, RPO 15 minutes, source cross region, manual failover, right? The T plus 2 disaster site is active, right? Data corruption, RTO 1 hour, right? RPO variable, source PITR backup, right? Point in time uh, backup, manual restore, T plus 1, clean data, right? So here you have a full backup in here. See that little dots, right? And then these ones are incremental backup, right? I think this might be incremental. This one possibly be full backup. This is a recovery point, right? Data flow that direction. So recovery time objective, recovery point objective. So cross-region backup. So cross-region copy in disaster recovery encrypted backup, right? Security compliance, automated copying, operational efficiency, right? Point in time recovery transaction log backup every 5 minutes, right? Backup retention from 1 to 35 days configurable. Automatic backup window scheduling during, uh, what is that? So low activity period, right? Low activity period. So low activity period, say automatic backup window, right? So manual snapshot. So use your initiate backup the storage until explicitly deleted. So it's not automatically deletion, so can be shared across the account and copied to other region. Perfect for pre-deployment backup. So RTO recovery time objective, right? Um, how long will it get up and running? That is called recovery time. RPO recovery point objective, how much data you can lose, right? So multi-availability zone recovery time objective is 1 to 2 minutes, right? Point in time recovery point objective about is 5 minutes. It's because of asynchronous data rate, right? You're going to lose some data, right? Okay, so we're going to talk about within what sort of integration we have. So this is a bit of a diagram. See that? So you've got MS and VPC, and in the private subnet you have RDS, and then you can have easy to instance accessing. Yes, elastic. load balancer accessing that, and then security wise you can use authentication through IAM, and Lambda can be accessed through API to RDS, and then CloudWatch you can database logs can be monitored using CloudWatch, and RDS can be accessed through S3, and then failover you can use Route 53. So see that this multi-tier application data tier RDS multi-availability zone, and then this is microservices like API gateway integration via Lambda, and this is the details. All right, we're going to talk about bridging RDS pattern exam analysis framework. I've got another decision tree here before I'm finishing this video. So identify type, scenario type, performance, cost, DR, map requirement to RDS feature, eliminate wrong choices systematically, apply decision matrix, right? And common exam traps, read replica for high availability, uh, not read replica is not for high availability. So standby replica is for high availability. Multi-availability zone for read scaling. That you can do in a one scenario, cluster deployment. Normal deployment, you can't use read replica. It's going to be standby replica. Aurora serverless for predictable workloads. It is for non-predictable auto scaling, right? Also, you have to think about Aurora is going to be about 20% more expensive than normal RDBMS, because this one is faster, 5 times faster than normal SQL, and then 3 times faster than PostgreSQL, right? And then it can ask from you a wrong backup retention period, right? Also, we're going to have a look at another decision tree, right? So this decision tree, exam decision tree, set an interactive flowchart. First, we look into a loads, workload, but this one going to be based on performance, cost optimization, high availability, and disaster recovery. So see whether we can understand that, right? Let's see whether we can zoom this one or horizontal scale. So you get horizontal scale here, right? So let's see horizontal scale or zoom too much. Let's go to auto scale. Auto scale, some of them I can't see, right? All right. So let's have a look at this pro chart, right? So this is RDS examination T. This is totally RDS, right? So workload is selected. You have selected RDS, and then going forward, right? So when it is a RDS, your requirement is a relational database system, but it's a performance scenario, right? Oh, okay. So performance scenario, read scaling needed. If you need a read replicas, right? If you need a read replicas, so you can go to read replicas, right? Read scaling needed. Then you have Aurora read replicas. I think you can go more than 5 read replicas. I think Aurora you can go to 15, right? And then write performance is critical, right? So write performance is critical, right? Write performance critical, right? Then Aurora serverless, because it's a faster, 5 times faster than SQL and 3 times faster than PostgreSQL. So then if it's faster, then auto scaling is needed. So you can go to auto scaling, right? Then you can go to cost optimization, right? Budget constraints, right? So budget constraint. Then you can go to normal RDS reserved instances, right? Because normal RDS instances are cheaper than Aurora. And then that is for variable workload, right? and then you go reserved instance option, right? Reserved instance option, you give more cheaper, right? Then you can go to Aurora reserved, right? And a predictable usage, right? Is for predictable, right? And then I go to high availability here, right? What is your RPO, RTO requirement, right? You need more RPO, RTO, right? And link time for recovery and time recovery and point recovery, right? And then if you depend on that, you can go to multi availability zone deployment, right? And then a 1 to 3 minute downtime if it's okay, right? And then you got a multi-region needed if you need a disaster recovery, right? And you need a disaster recovery, then you can go to Aurora multi-availability zone, right? The less than 1 minute failover, right? And then you move towards disaster recovery. Then you can see this is actually high availability disaster recovery. So cross-region backups. You want a cross-region backup, right? And then automated failover, right? And then you can go to cross-region read replica, right? Less than 1 second point objective, right? Recovery point objective is less than 1 second. So if you need it automated failover or a global DB, global distribution, and then you can have automated backup, right? Point in time recovery. So it's sort of a diagram gives you an idea, but it's also confusing some of them. But this is how you go to uh, design. And then finally, I want to discuss one or two things. Security, that encryption at rest, key management service, key selection, and VPC security code. You can use for protecting database instance, and IAM database authentication, those passwords, and then SSL enforcement. That's protected in transit, data in transit and data in rest, right? Um, all right. So that is one other thing I want to discuss, right? Because the video is getting bigger and bigger. I'm going to briefly discuss troubleshooting and log analytics overview. So RDS monitoring capabilities, real-time performance tracking for database health, multidimensional metric collection, automated alerting and notification system, historical data analysis and trending, right? Proactive monitoring prevents costly downtime and ensure optimal performance for mission critical application, essential for designing resilient database architecture in AWS. So error logs, right? And then slow query logs, right? And general logs you can have. All right. So this is RDS monitoring tools and services. So you can use CloudWatch metrics to database performance indicators, CPU memory and input output utilization, right? And customizable alarm threshold. And you can have a performance insights, right? Visual database, stored analytics, top SQL statement tracking, event identification, right? And these are the things you can get from so if you integrate with the CloudTrail, right? So you can track on user access patterns, permission change, configuration modifications, right? So you can do every API integrate interaction, right? Database creation, modification, deletion events, right? And then you can have security events in a cloud trail, right? And then regulatory compliance, right? Few more things. Metric security analysis for RDS. So you can have a guard duty RDS protection, machine learning powered threat detection, right? And then you can see VPC prologues, connection to connection source tracking, right? bandwidth utilization and monitoring, right? So security groups give you security and then traffic patterns. You can have a look at traffic patterns, right? Yeah, I believe these are the things you can do tracking with RDS, right? Um, all right, I think I'm going to end up the video in here. We'll see you guys from next video. Until then, thank you very much. Okay. We are in the discussion of AWS Solutions Architect, and we've been discussing with RDS, right? And now today we're going to go further discussing with the details of RDS. Right, okay. Now we're going to briefly discuss database types overview here and the relational databases as we discussed in the previous. So structured data organized tables with the rows and columns use SQL queries, SQL queries, and maintain ACID properties. So atomicity, consistency, isolation, durability. That's the properties integration. So that's the accuracy of databases. So if it's a ACID compliance, you have to use a relational database, and then basically we move into a semi-structured databases. So semi-structured databases like document databases, um, sort of a flexible format with nested structure like JSON, XML, JSON, right? So allow varying schemes with collections. So same example you can see under JSON document, right? See here. And then now we go to something similar to DynamoDB, NoSQL, key value database, simple key value pairs for parse retrieval, like a shopping cart. You can see the shopping cart. When you do shopping, you have your own shopping cart for user, and then you have another session as well, and you have cache, whatever the product you're putting into your shopping cart will be in a cache. So simply looks like a NoSQL database, right? And then we looking into databases and analytics services. So RDS. So we have these databases: MySQL, PostgreSQL, MariaDB, Oracle, Enterprise, and then Microsoft SQL Server, and then AWS Aurora, faster than 5 times of SQL, right? Mm, they are coming with these sort of automated patching, automated backup, scaling, right? And then the other type is NoSQL is specialized, DynamoDB, serverless with a millisecond latency, faster. And then document DB, MongoDB, compatible with the document store, and then relational databases with the Neptune graph database, time stream. Then you got a QLDB, mutable ledger database, and then mm, analytics and data lake, the new type of databases, not RDS or Redshift, petabyte scale data warehouse, huge data, petabyte. S3 is not a database, but data lake is storage. So you can use for application API interfaces. Then Athena, budget database with the per SQL queries charging, right? Mm. MS Glue ETL services with data catalog, and then you got EMR, right? Big data with the Hadoop and Spark, back processing, lake formation, data lake setup and governance, and minus is real-time data streaming, right? And then you got a memory caching for fast access. You have Redis cache clusters, and then you have MemoryDB, Redis compatible with durability. So sub-millisecond response times for that one, right? And then we're going to talk about exam strategies. How we going to select a different type of databases based on uh, what type of workload, right? So gives you an idea of what sort of questions you can get to the exam. Scenario based, real business requirement. How do you map the databases into real business requirement mapping? Then cost optimization. How do you deal with budget constraints? And then what sort of performance you need? And then you need to come up with the solutions with the security and compliance of your data in that region, right? So, solution elimination is strategy. So, read carefully, identify your key requirement, and then eliminate extremes, right? And then consider scale, future growth, and current status, and then security and regulatory requirement, right? So, common exam traps RDS versus DynamoDB. So in between the selection in between RDS and DynamoDB, you have to consider if it need to be ACID compliance or just need a eventual consistency, and then Redshift misconceptions, not for OLTP workloads. So Redshift is not for online transaction processing workloads. We're going to discuss this one soon. Aurora pricing. Aurora pricing is higher than normal RDS instances, but you need to keep remember that Aurora is faster than 5 times faster than normal RDBMS, like normal RDS offerings. No SQL overselling. So when SQL is actually better, you need to select that over no SQL like a DynamoDB. So decision tree, we're going to look into a decision tree, which is going to help you to select the right database type. So when you're looking into decision tree, so you have to select in between these three workload types. The first one is the OLTP, online transaction processing. That's sort of the e-commerce banking type database nature, and then online analytical processing. So that is sort of a data warehousing, a business analytics option, and then analytics, the totally a data warehousing, huge amount of streaming data, mainly the processing, and then step two is once you identify the workload, then you have to access the data structure, whether you need a relational database, document database, or NoSQL key value database, right? And then you need to consider what sort of performance requirement you needed, and then consider operational overhead preference. All right. So before I'm going to this database selection decision for exam scenarios, I'm going to explain you ACID compliance refer to a set of properties that ensure the reliability and consistency of database transactions. So basically bank transactions, e-commerce transactions. So reliability and consistency is really important. So it stand for ACID stand for atomic city, right? Consistency, isolation, and durability. So these properties guarantees that database operations are processed accurately, even in the face of errors or concurrent access, making ACID compliance essential for systems that require data integrity are really real. reliability. So see that your bank transactions, e-commerce transactions, they need to accurate. So you deductions the right amount from a credit card, and whatever you buying, they need to be accurate. So these asset compliance refers to the set of reliability and consistency, right? So that is what called ACID, right? So AWS database selection and decision tree for exam scenarios. So we're going to looking into a choose based on a workload requirement, right? So in this tree, so let's say you are in a prompt of deciding what you which database you're going to go with for the scenario, right? Okay, let's go from the left. So the first one is a OLTP. Is it an online transaction processing workload? That's need it's happening in a high concurrency, and then you need to have ACID compliance. So consistency of database and reliability is important, and then it's real-time operations, right? And then the middle one, you got OLAP, online analytical processing. So the nature of this type of database is complex queries. So you get a complex queries, the data warehousing, and then you have business intelligence. Let's say you have a sort of retail stores. Let's say you've got 10 retail stores, and you need to analyze your daily transaction. So is it a supermarket? You just need to get a uh, analyze departmental level, like your daily department, your produce department, your right, the you got another department, right, grocery department, and then you need to analyze your shopping carts or what's your shoppers buying. So that sort of is the analytical processing. And also then you go to analytics. So big data warehousing, so large databases, machine learning, stream processing. So you need to understanding intelligently analyzes huge amounts of data. So that is the workload types. You need to select what workload is I'm getting in the scenario, and then let's say you come up with an online transaction processing workload, and then you have to go to what sort of structured data, what sort of data type you need. Does it need to be structured? You need SQL queries, and does it need to be ACID transactions and normalized schemes, or is it a semi-structured? Is it a document type? Is your requirement that a JSON, BSON, right? XML, is that is that type, or do you need like key value, NoSQL, simple lookup, high performance, caching, and session storage, right? Is that type of nature, right? If it's a relational, you need a structured data, then you can go to fully manage AWS RDS solution, right? So you're patching, backups, scaling, monitoring happening in the background with AWS. And then that type of transaction, you need to go to manage RDS, right? So you can have read replicas, automated backup, and your requirement is traditional RDBMS. So you can select one of the available RDS, and then if you need a faster, 5 times faster than MySQL performance, uh, auto scaling storage, right, and global databases. So if you need a high performance RDBMS, you're separating it from a traditional DBMS, you can go to Aurora database, but you need to keep remember the Aurora pricing is a bit higher than normal RDBMS level, right? Okay, so that's if it's a structured database, but if it's a like a traditional legacy, or you want a more control over your RDBMS, then you have to go to a EC2 plus DB. So you're going to get a root access like full control, right? And then you need a customer configuration, right? Regulatory compliance, you need to have full control. So that's legacy systems or OS level access. Then you have to go with EC2 plus DB option, right? And then if you don't need a structured, and then you need a semi-structured, right? You get in data like JSON, right? XML type of data. You have a flexible schema, not like a, uh, different columns with tables. So then you have a MongoDB compatibility. Then you can go to DocumentDB, MongoDB option, right? And then that is a type of MongoDB workloads, right? Or if your requirement is no SQL database, right? Simple lookup, but you need a high performance. You need a caching, session storage, like you have a session, then you can have a last cache, right? For millisecond, microsecond latency, right? You have a session layer, then NoSQL key value, millisecond latency, then you can go to DynamoDB is your best option. All right. So then in the middle, if you go to you don't have OLTP, so you have OLAP, online analytical processing. So business intelligence, like you have to intelligence, you have to let's say the real retail company, and you doing a lot of transaction every day, and then you have to analyze your frequent customer data, like your shoppers, right? And then complex queries, data warehousing, business intelligence. Then you got an option like, right, high throughput, performance critical, right? Columnar storage, parallel processing. You want you getting a petabyte scale data, it's a huge amount of data. Then you got a Redshift, right? Redshift. You can use AWS Redshift, right? And then if you have a cost optimization budget constraints, right? You can only use whatever your queries, whatever you filter your data and coming up with a per query. Then you can go with Amazon Athena, right? Athena is going to give you a pay per query, right? Query type of a database. Um, that is some and hook and you combine with Athena to use S3 markets, right? The cheaper way, right? Then use Athena. And the last, so big data processing, you're going to get a large data set. Machine learning is involved. Stream of data flowing coming in. Your data is a real-time streaming coming up, like using IoT devices, you're getting a consistence of data. Then you can go to Kinesis, right? Kinesis is a real-time streaming, right? And you get a machine learning sort of data. But if this is like a batch processing, right? Large data sets, ETL operations, Hadoop and Spark, then you can go with the EMR, right? Uh, Big data analysis, machine learning, Hadoop Spark is nature of your database. So then you have to go to the EMR. So that is how AWS database selection decision tree is coming up, right? So that is the decision tree. Now we're going to looking into quickly the identifying workload type, whatever we discussed. So three workloads we discussed: OLTP, OLAP, and analytics. So online transaction processing, online analytics processing, and then analytics. So I summarize OLTP workloads, OLAP workload, and analytics workload, right? So OLTP workloads are high frequency transactions like bank transactions, e-commerce, asset compliance. You know what is asset? I explained that. Data consistency and durability and accuracy, low latency, less than 5 milliseconds, high concurrent users, so frequent users been using them. And then analytics workloads, you got a complex queries, historical analysis, so you're getting everyday data, and rate heavy operations, dimensional modeling, right? And then analytics workloads, so big data processing, machine learning pipelines, streaming data. So you get the streaming data, unstructured data, a lot of unstructured data coming, right? Um, so each case, so OLTP, you need to asset compliance. So you can use RDS and then MySQL, PostgreSQL, Amazon Aurora, serverless option, but it's 5 times faster, bit of expensive. And if you have a NoSQL option, you can go to DynamoDB millisecond latency. Uh, then OLAP, Redshift, petabyte of data. That means a huge business intelligence. And then Amazon Athena, integrated with the S3 buckets, plus per SQL charging, budget option. And then you can go quick site, BI visualization, and then normal analytics, huge data. So if you have a Hadoop Spark nature, then Amazon EMR. And if you're getting a Hadoop Spark with the batch processing as well, and then Kinesis is streaming data coming up, then you can go to Kinesis, and machine learning workflows, you can go with the SageMaker. All right, so I've got another one more selection decision tree, a bit of a different scenarios, so whatever we discussed, but it's going to help you as well. So decision tree, what type of workload do you have? So we're looking for keywords like transaction, analytics, or real time. So transaction means OLTP workload. Analytics means OLAP, and then real-time streaming is more related to data warehouse, big data analysis, right? So OLTP workload indicators high concurrent users, frequent read-write operations, ACID compliance, low latency critical. So exam words like you have an e-commerce website, so you have user sessions, or it's a financial transactions like a bank transaction. So then it's a indication of a OLTP, and then high performing OLTP, microsecond latency, millions of requests per second, auto scaling required. So gaming leaderboards, IoT device data is coming up, and that can be a NoSQL if you have more SQL, single digit millisecond latency, serverless option, right? The best for web, mobile apps, gaming, IoT, right? That's going to be DynamoDB, and the cost is per $1.25 so million requests, right? And then DynamoDB, right? You select DynamoDB, gives you sort of this sort of performance. The words coming up with a single digit millisecond uh, latency throughput 40,000 plus RCU, WCU, and then you got auto scaling available, right? So exam TPs choose per millisecond, sorry, microsecond latency requirement. And if it's you need a faster, so 5 times faster than MySQL, right? And auto scaling storage, the high performance apps, right? Normally it's 20% more costier than normal RDBMS, right? And then if you have a standard OLTP, traditional applications, relational database model, so scenarios, web applications, CRM systems, it's not really you need like online transaction. So you can go to one of these RDS instances, normal RDS provided by AWS, right? And you got multiple engine option. Which one is good for your choice? You can use. So you got like you can have MySQL, PostgreSQL, and then you can have enterprise like applications like uh, Oracle, right? Sort of enterprise as well. Whatever best for you are your traditional applications. So the cost is depend on the instance plus the storage pricing. So you can select whatever you can have a storage optimized, IOPS optimized, or memory optimized sort of things, right? And so RDS performance, you can have IOPS, right? Input output per second up to 8,000 in the IO2 level. And you can go up to storage up to 64 terabytes, right? And then high availability, you can have multi availability zone, uh, for instance, in availability zones, standby replica, that's for high availability, right? So standard choice for relational workload. I just need to remind you multi availability zone for high availability. So that's going to be standby replica, so you can use that one for as a read replica. But if you uh, deploy cluster deployment in availability zone with synchronous replica, then you can use them for read replica as well. So keep remember that one, right? And then you can have them in another region for like disaster recovery with the asynchronous read replica as well, right? This one actually I'm going to open one of these AWS documentation forum, and I'm going to go through this one, right? I just explained with this RDS that one. All right, so then if your workload is OLAP, analytical workload indicators, right? So this one is a words indicate complex analytical queries, and you have sort of historical data analysis, collected data throughout the time, right? Maybe month, years, and then you need to batch processing, and then you got a data warehouse. So it might be you need to business intelligence analysis a huge amount of retail supermarket data, and you want a reporting, you want a business intelligence, so selling products, right? Which hours, right? Oh, you got a data warehouse, then you got two options, right? So complex analytics, you have a petabyte scale data, complex join operations, columnar storage benefits, historical analysis, then you can go to a Redshift petabyte scale, right? Still, you have sort of a SQL interface, and this is best for business intelligence. So it's costing you 25 cents per hour in a TC2 large instance if you select like your EC2, right? Redshift. And here the performance in Redshift. So compression up to 10 times, right? So you can have parallel processing of this data, and then I get a result caching. So it's really good for data warehouse scenarios. All right, then you got analytics, but you're going to store your data in S3 buckets, right? So now infrastructure management, you're going to pay per query, right? This is basically good for log analysis, then one-time reports, right? Then if that's your nature of workload is like this one, so you can go Amazon Athena, right? That's a serverless courier service. Query S3 data directly, the standard SQL, and best for ad hoc analysis, right? $5 for TB data scan. So Athena's performance is serverless and partition pruning, base point frequent like ad hoc queries, right? So the last one going to be EMR, right? Hadoop processing, and then you're going to be in if you have big data and machine learning, right? Data science, ETL processing. So you go to EMR. So that's the second part of this AWS selection addition tree, right? Um, all right. Let's see the next step from next video. Until then, thank you very much.